Hello, my name is Britta and we have done artificial intelligence projects for years. And actually, not only research, when you have enough time to clean up data sets, our solution runs 24/7 at client site, analyzing production data in real time. For doing so, data must be okay, because bad data leads to bad analytics results. And have a guess who is to blame if analytics results are not good? Obviously, analytics software. Well, we have had quite some discussions with clients, proving them problems with data quality. However, finger pointing does not help anybody. Therefore, we have developed flexible algorithms that take care that your data is fit for artificial intelligence analytics. Of course, our artificial intelligence cannot do magic. But we also use AI for pre-processing, for fixing data problems, or at least for target-oriented information. In that case, the responsible person can solve the problem in short time. Let me show you the three major problems and, of course, how you can solve them in a reliable way forever. Let's get started with data availability. Data needs to be available, that's an obvious fact. And everywhere you can hear that more and more data is available. Of course, that is true. In times of Industry 4.0, machinery is IoT enabled, meaning that machineries are equipped by the supplier with sensors and connectivity. For sure, this is much better than adding sensors to your machinery individually. However, you cannot replace all your machinery used in your factories by IoT-enabled machinery. I mean, computers have a lifespan from a few years, but with industrial machinery it's different. The longest payback period I heard of was in steel industry. They talk of 50 years. Of course, this is extreme. However, old and still good machinery is used in factories. Thus, no automatic data delivery is possible. What is the consequence? Installing sensors, realizing connectivity. Thus, many data sources need to be connected. The more data sources you have, the more complicated it can get. On the one hand, sensors can fail. On the other hand, sensors might deliver very good data, but connectivity to the database is not stable, or even sometimes databases can temporarily fail to work well. At the end, data, small or big, is missing or is delivered in a delayed way. As long as data is missing, for sure, analytics cannot be that reliable anymore. Obvious. This is not only true for the exact time period when data is missing, but also for neighboring periods. Often even partial analysis is not possible anymore. The only thing you can do is to make sure that missing data can be synchronized afterwards. This increases server load significantly. There is a solution for this problem. The keywords are fast transparency. On the one hand, algorithms detect quickly which data is missing. Live messages are sent to the responsible people. Here they can see exactly which data is missing, and on the other hand, algorithms discover reasons for missing data. This ensures fast transparency and also fast reaction time for problem solving. The problem does not accumulate, but it is nipped almost in the bud. Thus, additional load on operative system is low. Here we are, data is available. That's a good start. Now let's have a look at data quality. In production processes, for example, there is high complexity due to high variant diversity. A huge number of different products is produced. Therefore, production values change between production lines, between working station and products. Consequently, data must be assessed for each single part individually. Here the keyword is semantic checks. If data is available and good for component X, produced in production line 1, it does not mean that data is good for the same component X produced in another production line. The solution is given by a so-called semantic model. It checks data quality use case specific. There are automatic semantic checks which use live messages to inform about problems. Here, too, reasons for those problems are discovered. Thus, you can also nip problems in the bud, get transparency quickly and solve the problem quickly. Conclusion: good data is possible using algorithms which inform us humans use case specific. Let's now have a look at the third problem. Everybody is talking about big data. However, Sometimes clients tell us that acceptance of data analytics tools could not be reached because it took too long to get the desired results displayed on the screen. Unfortunately, often we see that architecture is not taking care of complex mass data processing. Whether you have a data lake or only a data pond, fast access to relevant data is essential. To do so, we do not have redundant data. Our artificial intelligence accesses even different data sources, and only a very small part of data is transformed and kept redundantly, if necessary. The keyword is targeted data transformation. This is target-oriented data processing, which reduces query duration in user cockpits to a minimum. In this way, you can work efficiently with your data, even if you analyze large time periods. In addition, server load is minimized. The biggest compliment a client can give us in this context is, "I really have fun working with predictive intelligence." And if you also want to have fun when working with complex data analytics, then please get in touch. I will be pleased to inform you about our references and share our lessons learned with you. Looking forward to hearing from you.